Okay, this is part two, graphing radicals, with the focus being on cube roots. Yesterday, I spoke about the square roots, and they are similar. The difference being that a cube root has an index that shows on the radical. So the index 3 represents cube, okay? So they have the same rules. What you would do is you would look at the sign of x, and underneath the radical, you can see here that we have two positive x's, and then we have a positive y and a negative y, which tells us, if we look at the graph or the coordinate plane, where those graphs will be, the end behavior will be going towards. The difference between the square root and a cube root graph is the square root has like a half of a parabola. A cube root has half of a parabola on one side, and then it flips and has the half on the other side. So kind of like what I just drew. And again, that depends on your signs. So you really only have two options. You're either going to have your graph that's going up the way that I just drew it, or you're going to have it where it actually flips and it reflects and it'll go the opposite way. Those are my only two choices. So I've shown you what it looks like. So just take a look at this little chart here. Okay. When we're talking about transformations, this is the exact same notes that you took yesterday when you were talking about, when I was talking about square roots. The only difference again is that the index. The index now shows the number 3, which represents a cube root function. The outside values, again, are representative of y. So whatever's on the outside here, that's going to be y values. What's on the inside is going to deal with your x values. So inside meaning it's under that radical. Okay. And then h and k will still be your vertex. H, you change the sign. K, you keep it. Let's go over, and this is what it's going to look like if I have an actual cube root function. So in this case, y equals -2, cube root of x plus 2 minus 3. All right, so I went ahead and labeled the a, the h, and the k for you. And I notice also that it is going to reflect because it has a negative sign in front of my a. So this is another method that some people use. They use the table method. And they typically take the numbers -8, -1, 0, 1, and 8, because those are numbers that you can easily put in a calculator and take the cube root of, and it will give you a whole number. So if I took the cube root of -8, that's just asking me what number times itself 3 times will give me -8. Well, that's -2. So if I have 3 of those numbers, they no longer remain under the radical. The answer is simply -2. So that's why your y value here is -2. And I did that for all of my x values. So for -1, when I did the cube root of it, I ended up with -1, so on and so forth. All right, so now this is the part that some people, it's kind of tricky, but let's go back to, well, let's change this here. Up under the radical. So x minus is part of what the notes told you. Well, in order to get to this plus, I have to also have a negative h. So negative h in this case is going to be 2. And then for the k, like I told you in the square root video, you do not change the sign, so it's still -3. So if I take the h and the k, that's going to be my vertex, -2, -3. So basically the center of my graph, that's what this is going to represent. So this is important to find out. What I want to do now is I want to take the x value, which is the -2, and on my table, I'm going to take that -2 and I'm going to subtract it from every one of those values that are shown there. So that's only for my x values, right? So now for my y values, which is everything that's outside of that radical, I am going to take, and I'm going to, so I'm going to take the negative a part and I'm going to put it in front of the y that's shown in my table. So this will become -2 all the way down, -2, -2, -2, -2. And then what I'm going to do is I'm going to make sure that I'm multiplying it because that's what's happening in my original problem. The -2 is being multiplied times that radical 3, x plus 2. So that's what I'm doing. So make sure you put your parentheses, and this is important because now you have to take the k part, which is -3, and that's going to go after. You do not have to do it this way. This is just another method. You can do this also with your square root. I didn't show you this method with the square root, but you can use this method. All right, so now once I get this information, I'm going to create a new table, which is just a simplified version of this information. So for my x values, -8 plus -2 is -10. And then on this side, my y values, -2 times -2 is +4. +4 minus 3 is 1. And then I would just simplify all the way down. And again, 8 minus 2 is going to give me 6. And if I go back up here, the -2 times -1 is +2. 2 minus 3 is -1. And then I just keep doing the math until I simplify. The purpose of doing this is because now this is the actual table where I can plot my points. I still need this. This is the center of my graph. All right, so we said -2 and -3. So we're going to go over 1, 2, 1, 2, 3. And this is my vertex. Now, yesterday I taught you on your square root video that if you were to look at the sign of x that's under the radical and then the sign of y that's outside, so x is positive and y is negative, your graph is going to go in that direction. So positive and negative, looking at my coordinates, that means my graph is going towards quadrant 4. So now I can kind of eyeball this, or I can use that table that I literally just created here and plot points, which is what I'm going to do that. And then you can see that it is going towards quadrant 4 like it said it would. So I'm going to go over 6, 1, 2, 3, 4, 5, 6, down -7, 1, 2, 3, 4, 5, 6, 7. It would have helped if I numbered these. I'm just picking some random points here. -3 and -1. -2, we already did that one. -1, -5, 2, 3, 4, 5. Okay, what else did we have? -10, +1. And of course, you don't have to do all of these. You know what the shape of the graph is going to look like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I said +1. So you know that the graph is going to look like either a stretched out S or a backward stretched out S. So it's going to look something like this, but as I stated before, it's going towards quadrant 4. We knew that because my X was positive and my Y was negative. All right, so that's what my graph should look like. Let's verify using a calculator. Okay, so if I'm using a graphing calculator, what I would do is I would go to my Y equals button here, type in the information. Let me go back here so you can see what the original problem was. So it was that -2 cube root. To get to cube root, you have to hit the math button. And then once you hit the math button, it's number 4, okay? To get out of that, you can do second and then mode, which is quit. So going back to my Y equals, put this information in. And once you go past that radical, make sure you arrow over to add the K part. Now you can go to your graph. And it's kind of giving you an idea of what it should look like, but we already see it right here. So let's go back to my picture. So that's what it should look like, something similar to that. And then if I wanted the exact points, again, I could have just used my calculator, which showed me my points, which are just like my table that I created. So -3, -1, -2, -3, so on and so forth. You do not have to use this method. That's just another way to do it. All right, so now whenever you are talking about the cube root functions, the domain and range will be super easy. It's always the same. So your domain and your range will always be from -infinity to +infinity, both of them. And that's because if you look at the graph, you will see both have arrows on them. So that means it goes on and on forever. And in terms of increasing or decreasing, so the interval of increase or decrease, well, what I'm doing is I'm following my graph. What's happening? It's going down, so it's decreasing. And if I want to know exactly what the points are where it's decreasing, it's going to be the exact same as my domain because, again, my interval of increase or decrease refers to my x values, and my domain refers to my x values as well. So decreasing from -infinity to +infinity. And that's it, you guys. So you can take this method and you can use it again, like I said, for your square root if you wanted to, but you don't have to.